So we have completed the discussion on rank nullity theorem. We have proved that theorem yesterday class, and in this class we'll discuss about what is matrix of a linear transformation and how to write uh, how to write a matrix of the linear transformation for a change of basis followed by inner product spaces and orthogonality. Okay, so I'm going to uh, share my screen. So can you see the screen? Are you seeing the screen?
Yes, sir.
Right. So in yesterday's class, we have proved this theorem, which is rank nullity theorem. It says a dimension of a vector space. If you have a linear map from a finite dimensional vector space to another vector space, then the theorem says that dimension of the vector space V is equal to dimension of the kernel space plus dimension of the image space or the range space, or you can say n equal to rank plus nullity, where n is the dimension of the domain vector space. Okay. And the next definition is about uh, matrix representation of a linear operator. And what is linear operator? Linear operator is a linear mapping which is mapping from the vector space to itself. Okay. So linear mapping, sorry. So so linear mapping is a function from V to U in general, V to U, and linear operator is a function from V to itself. Okay, so linear operator is a special case of linear mapping, linear transformation. Okay, so that is what it is written here. T is a linear operator from a vector space to V to itself. Okay, so then what do you mean by matrix of this linear transformation? So instead of f, it is written as t. Okay, your linear operator is called as t from a vector space v to another vector space v. Okay, so then if you are supposing that u1, u2, and so on, un are forming a basis of this vector space, then they will have images under this mapping T, right? So you have a mapping from a vector space V to V, okay, and the basis of this vector space are the elements which are u1, u2, and so on, un. Because this is a mapping, each element will have a image, that is T of u1, this is T of u2, and so on, T of un, right? And because these elements are also elements of V, and V is having a basis u, that means each element can be expressed as a linear combination of the elements of these basis elements. Because basis means any element can be expressed as a linear combination of those elements, because both the spaces are same, and this is the basis, and because T of un is also an element of V, this T of un can be expressed as a linear combination of these elements. Okay, so express this element T of u1 as a linear combination of basis elements. Similarly, express T of u2 as a linear combination of the remaining basis elements, and so on. So for each of the image of the basis element, okay, you write the corresponding linear combination of the basis elements. Then what is matrix of the linear transformation? What are these a11, a12, and so on, a1n called? Can you tell me? They are the coordinate vector for this element T of u1, right? Do you remember that coordinate vector? What is coordinate vector of right here? So what is a coordinate vector? Coordinate vector of a vector with respect to the basis E equal to, if you are writing V as a1 e1 plus a2 v2 plus e2 plus and so on plus an en. Then coordinate vector is nothing but a1 a2 and so on an, or sometimes we may write it as a column matrix a1 a2 and so on a. Okay, now instead of v, your vector is a t of u1. So t of u1 you are writing it as a11 u1 plus a12 u2 plus and so on a1n uh, un. Okay, what are u1 u2 u3 un? That is nothing but basis, right? So basis of what? Basis of the vector space v. Okay, u1 u2 and so on un. Okay, so for each of the image element you have a, you can write, okay, this as a linear combination. So this is a21 u1 plus a22 u2 plus and so on plus a2n u2 and so on. T of un would be an1 u1 plus an2 u2 plus and so on plus ann u1. And what is matrix of the linear transformation? You write these coordinate vectors as a columns. Okay, so with respect to the basis b, that is nothing but first, how do you write the quotient matrix? Write the quotient like that. You write the quotient matrix a11, a12, and so on, a1n. Okay, a21, a22, and so on, a2n, and so on, an1, an2, and so on, an. Then you take the transpose. Then you take the transpose. That means what? You write the coordinate vector. You write the coordinate vector in this way. Okay, that means the coordinate vector of each uh, image of the basis element is going to be the matrix. Okay, so a11, a12 and so on, you write it as a1n. Next you write it as a21, a22 and so on, you write it as a2n and so on, you write it as an1, an2 and so on, ann. So this is called matrix of the linear transformation with respect to the given basis b. Okay, so when you change the basis, then the matrix of the transformation will change, because you are writing collecting the coordinates with reference to this basis, right? So that is what it is written here. Okay, so it is a transpose. It is a transpose of the above coefficient matrix. Okay, you take the coefficient matrix and take the transpose. That is called the matrix of the linear transformation. Here it is termed as S. It is basis is termed as S. Therefore, it is a matrix of the transformation with respect to the basis S. Okay. So that is nothing but the coordinate vector of the first image t of u1. This is written in a column. Second coordinate vector of t of u2 and so on. Last coordinate. This must be t of un. Okay, t of un of the last vector. Okay, see this example here. So you have a linear operator from r square to r square. Okay, so I said there can be several bases. There can be several bases for a dimension for a given vector space. So this is one basis, standard basis. This is also another basis, because these two are linearly independent, and any and number of linearly independent vectors are 2. For a mass vector space of dimension 2, any two linearly independent vectors will span the entire space from the basis. So here you are asked to find out the matrix of the transformation with respect to standard basis, and also you are asked to write down the matrix of the transformation with respect to the another basis. Okay, so how do you find out matrix of the linear transformation with respect to the standard basis? What you have to do is you have to map, you have to find out the image of each basis element. You substitute 1 comma 0 in this function. Then what you get? Find out f of e1. Okay, so when you substitute 1 comma 0, you will get 2. You can say 2, and if you substitute 1 comma 0 here, 4 minus 0 is 4. 4, it must be, I think they have written a mistake. Basis element f of, it is not it is written here, print mistake again. See, this is 2 4. Okay, So so this is when you substitute 1 comma 0 here, you will get 2. When you substitute 1 comma 0, you will get 4. How can you write 2 comma 4 as a linear combination of these two elements? 2 into 1 comma 0 plus 4 into 0 comma 1. Am I right? So this is nothing but 2e1 plus 4e2. Therefore, what is the coordinate vector for this? 2 comma 4. You can see here 2 comma 4. Similarly, so find out the image of 0. Find out the image of f under the mapping 0 comma 1. Substitute 0 comma 1 here. When you substitute x equal to 0, y equal to 1, 3. You will get 3. When you substitute x equal to 0 and y equal to 1, you will get minus 5. So how do you write 3 comma minus 5 as a linear combination of two basis elements? 3 into 1 comma 0 plus minus 5 into 0 comma 1. That means 3e1 minus 5e2. So that is what is written. So then what is the matrix of the transformation with respect to the standard basis here? You write these coordinate vectors. You write these coordinate vectors as a column. See 2, 4, first column, 3, minus 5, second column. That's it. Now do you understand how to find out the matrix of a linear transformation with respect to a given basis for the standard basis? You find out the image of the basis element. Write down the image, each image as a linear combination of the given basis elements. Then find out the coordinate vectors, write in a column that forms a matrix. Okay. Now you see, instead of standard basis, if you're asked to find out the matrix of the transformation with respect to the another basis 1 comma 2, 2 comma, substitute 1 comma 2 here, 1 comma 2. When you substitute 1 comma 2 here, what happens? 2 ones are 2, 3 twos are 6. 6 plus 2 is 8. Can you see? 6 plus 2 is 8. So f of 1 comma 2 is f of 1 comma 2 is f of I'll do it in the 1 minute. Okay. So let me copy this function. Okay. F of x comma y equal to, what is f of x comma 2x plus 3y? 2x 2x plus 3y and 4x minus 5, 4x minus 5. Okay. And what is the basis element? Basis is 1 2 2 5. Okay. 1 2 2 5. Okay. You may call this as let us say u1 comma u2 for the time. Okay. Now I want to find out the matrix of the linear transform with respect to this basis. Okay. So find out the image elements. What is f of u1? What is f of u1? F of 1 comma 2. Please substitute and tell me quickly. Substitute 1 comma 2 here. F of 1 comma 2. 2 plus 2
8.
plus 6, 8. And what is the other element? 4 minus, substitute x equal to 1 and y equal to 2. 4 minus 10. What is 4 minus 10? Minus 6. Am I right? Am I right? Or? Similarly, what is
Yes.
f? What is f of u2? F of 2 comma 5. What is f of 2 comma 5? Substitute 2 and 5 here. 2 2s are 4, 5 3s are 15. 15 plus 4, 19. And 2 2s are 4. Sorry. 4 2s are 8 minus 5 5s are 25. What is 8? 8 minus 25?
Minus 7.
17, right? So minus 17. So this is the image. Now what is your point? You have to write it as a linear combination of u1 and u2. That means you have to write it as something like x into, okay, x into u1 plus y into u2, and this may be something like a into u1 plus b into u2. Find out find out x y a b. Okay, so how do you find out? So 8 comma 6 is equal to x into u1. What is u1? 1 comma 2. Okay, plus y into u2. What is u2? 2 comma 5. That means what? This is equal to x plus 2y. X plus 2y and other one is 2x plus 5. Am I right? Now you know two points are equal if and only the corresponding points are equal. That means x plus 2y equal to 8 and 2x plus 5y equal to 6. Solve this. That means 2x plus 2y, 2x plus 4y equal to 16, 2x plus 5y equal to 6. So when you solve this, you will get minus y equal to minus 10. That means, minus y equal to 10. That means y equal to minus 10. So when y equal to minus 10, what will be x? So x equal to 8 plus 2y. That means 8 plus 2 into minus 10. That means 8 minus 20 equal to minus 4, minus 12. Okay. So what are the coordinate vectors for this one? X equal to minus 12 u1 and y is minus 10 u2. Okay. Now what is our similarly find out the coordinate vectors for f of u2. I want 19 comma minus 7 to be written as some a into u1. What is u1? 1 comma 2 plus b into u2. What is u2? 2 comma 5. That means a plus 2b and next 2a plus 5. Now equate this equate the corresponding elements. So a plus 2b must be equal to 19. 2a plus 5b equal to minus 17. That means 2a plus 2b equal to 38. Okay, and 2a plus 5b. Okay, 2a plus 5b equal to minus 17. Subtract. Okay, minus 3b equal to what is 38 minus minus of minus plus. Am I right? So it is going to be 4855. Am I right? 4550. So what is b? Minus 55 by 3. Okay. So tell me if there is any calculation mistake. So a equal to 19 minus 2b, that is 19 plus 2 into 55 by 3. Please simplify and tell me this value. 19 3s are 57. Please tell me this value. Okay. So that this is equal to, okay, so f of u1 equal to minus 12 u1. Okay. F of u1 equal to minus 12, sorry, minus 12 u1 minus 10 u2 minus 10 u2. Similarly, f of u2. Can you tell me that a and b values? Find out a and b values. Are you there? Okay. So once you write a and b values, then matrix of the transformation with respect to b is going to be write down this coordinate vector. What is the coordinate vector? Minus 12 minus 10 is the coordinate vector of the first image. Similarly, find out the a and b values. You put those a and b values here. That is going to be the matrix of the transformation with respect to the new basis. Okay. See here. One, two, two, five. What are the images? 8 and minus 6. Is that what we got? 8 and minus 6. Is this minus 6? Okay, I think I have totally made it mistake. This is minus 6, right? Okay, so when it is minus 6, then it is going to be minus 6. When I am subtracting, it is going to be 22, right? So y equal to minus 22. Is that what we got? No, minus 22. See here, y equal to minus 22. So when you substitute y equal to minus 22, you will get x value. In a similar way, you can find out a and b values and get the answer. Okay, so you just have to put the coordinate vector as a column so that you form a matrix that is called matrix of the transformation with respect to the basis. Is it fine? Are you with me? Shall I proceed?
Yes, sir.
Right. So that is what I would like to say. Okay. So now what is a change of basis? Okay. So what is a change of basis? Read it. Okay. So you can have two bases. Okay. For a same vector space, right? You have a vector space. Okay. You have a vector space V. This can be generated by S. Same space can be generated by another space S dash. Okay. Then if you are writing these elements, as a linear combination of these elements, okay, then you take these coefficients and transpose it. That is called basis of the that is called the change of basis matrix or transformation matrix. Okay, so you find out the coordinate vectors. You find out the coordinate vectors of one basis elements with respect to the one basis with respect to the another basis. Then put them in a matrix. Okay, that matrix is called transition matrix or change of basis matrix. Now here there is no linear transformation. Then there is no linear transformation. Okay, you just have to write one matrix. One, suppose in this case you take what are these elements for the same vector space in the previous problem. Uh, these are the two bases, right? For this r square, one basis is 1 0 and 0 1, and another basis is span off. Okay, another basis is 1 2 1 2 5. Okay, 1 0 0 1 1 2 2 5. So basis 1 3 1 1 0 0 1. Basis 2 is 1 2 1 2 5. 1 2 1 2 1 2 and 2 5. Okay, so both are basis of r square only. Both are basis of r square only. Okay, so you call this as e1 e2. You call this as u1 u2. You call this as u1 and u2. So what it says, if you are writing each element of the second basis as a linear combination of the elements of the first basis, then the transpose of the quotient matrix that is so obtained is called the transition matrix from old basis to the new basis. From old basis to the new basis. Okay, so okay, so in this case, if you are writing 1 comma 2 as a linear combination of basis elements of these two, okay, so then what is that called? You can write it as 1 into 1 comma 0 plus 2 into 0 comma 1. Okay, so what is the second point? 2 comma 5 can be written as 2 into 1 comma 0 plus 5 into 0 comma 1. Okay, so then what is the transition matrix? What is the transition matrix with respect to the old basis? Okay, so that is nothing but you put these elements in the column 1 2 and you put these elements in the column 2, 5. This is the transition matrix with respect to the old basis B1. Similarly, if you want the transition matrix with respect to the new basis B2, okay, that means you have to write down U1, U2 in terms of U1 and U2. Okay, so write down 1 comma 0 as a linear combination of x U1 plus y U2. Okay, similarly, you write down 0 comma 1 as a linear combination of, okay, some a U1 plus b U2. Then what is this called? Then if you put these coordinate vectors x, y and ab, okay, x, y and ab, that is called matrix of the transformation with respect to the new basis. That is a transition matrix. Okay, so what it is telling is write down the elements, write down the elements of one basis, okay, as a linear combination of the elements of the another basis. Then you take the transpose of the quotient matrix, okay, which is so obtained, that is called the change of basis. Okay, so you can see an example here, maybe here. So there are two bases are given. Okay, consider the change. So u1 v2 s is one basis 1 2 3 5. Another basis is 1 minus 1 1 minus 2. Okay, find the change of basis p from s to new basis s dash. Okay, you're asked to change the new basis from s to s dash. Okay, that means what you have to do, okay, you have to write each of these elements as a linear combination of these two elements. Okay, so 1 minus 1 is written as a linear combination of first basis elements x into 1 comma 2 y into 3 comma 4. We also write down the next element as a linear combination of the first element, first basis elements. Okay, 1 comma, again there is a mistake here, this is 1 comma minus 2, this must be 1 comma minus 2 as a linear combination of 1 comma 2 and 3 comma 5. Okay, I'm changing that one, there is a mistake here, this must be 1 comma minus 2, or because both cannot be same, this can be, this has to be minus 2. So then when you equate the elements, okay, x plus 3y, x plus 3y equal to 1, 2x plus 5y equal to minus 1. Okay, similarly x plus 3y equal to 1 and 2x plus 5y, 2x plus 5y must be minus 2, minus 2. Okay, so when you solve these two elements you will get x and y, when you solve these two elements you will get again x and y. You put these elements in the matrix 8 minus 8 comma 3 minus 8 comma 3, and these elements may be mistake, okay, may wrong because of this selection, this is 1 minus 2 actually. Okay, so you put those elements here, then the matrix is called the transition matrix from the old basis to the new basis. Is that okay? Similarly, you can find out a transition matrix from this basis to this basis. Okay, and that matrix is nothing but inverse of this matrix. Okay, if you compute, you will get a transition matrix from this basis to this basis, this one, and you will observe that these two are inverse to each other. Okay, so note that Q equal to P inverse. Okay, so once you have a transition matrix from one basis to another matrix, if somebody asks you to find out the other way, simply find out the matrix. Again, don't repeat the process. Simply find out the inverse of the matrix. That is going to be the transition matrix from the reverse way. Okay, is that clear? Okay, so we have learned two things. One is how to find out matrix of a linear operator, matrix of a linear operator. Okay, other one is what is the matrix of the change of basis, what is the matrix of the change of basis, or what is the change of basis matrix. Okay, so these are the two concepts, and these things you can skip or you can just have a reading when I share it. So next